Thrillville, amusement park destination.
Okay, so our project is titled Thrillville, and we decided to make an amusement park about each unit in physics, or a ride about each unit in physics. So first we have the roller coaster. This roller coaster is the epitome of the use of physics in an amusement park. They work using potential and kinetic energy along with Newton's first law of motion. The only mechanical device used during the ride is the pulley or motor that brings the cart to the top of the first hill. From there on, physics takes over as the ascent to the top of the hill creates potential energy. Once the cart releases, kinetic energy takes over and causes the cart to follow the track. The entire ride is a balance and exchange between potential and kinetic energy since no motor is used. Roller coasters use Newton's first law of motion, which states that objects in motion will stay in motion unless acted upon by something else. This is helpful for roller coasters, that way they continue moving throughout their whole ride and do not get stuck going up tracks.
What's the physics behind your favorite amusement park ride? First, there's a transfer of energy. Being up in a high-hanging cart, you have increased your potential energy. Hypothetically, say the wind were to blow. The effect would be resonance on the wire, creating a hopefully small longitudinal wave along the ride. Resonance is when the medium, in this case the rope, is vibrating at its natural frequency. This is the phenomenon that causes glass to shatter when someone sings at a certain pitch. Since the other end of the tramline wire is fixed, the wave would invert and change its phase. The two waves would cancel out, creating a destructive interference. As shown, even aerial tramlines have aspects of and utilize the laws of physics.
The drop tower ride relates to physics by its connection to the concept of free fall. Real drop towers apply a particular force to the car depending on the mass of the passengers in order to make the car rise. This sensation causes passengers to feel the effect of their masses, so when they drop, they feel weightless. Once the drop tower reaches its maximum height, the force keeping the car suspended in the air stops, and the force of gravity, which is G equals 9.8 meters per second, takes over, which makes the car fall. No matter if the car is filled with babies or sumo wrestlers, the ride will still fall at the same speed.
Ride D are bumper cars, but is it really physics and bumper cars? Newton's first law states that an object in motion will remain in motion and an object at rest will stay at rest unless acted on by outside forces. For the bumper cars, that means that each bumper car will continue to move at its respective speed unless it collides with another bumper car. Depending on the speed, the bumper cars will each resist differently to the impact of the other cars. Newton's second law states that the greater the mass of an object, the harder it is for it to change its speed. Because companies tend to make each bumper car weigh the same amount, the more people in each car, the more mass is added to the cart. More mass makes it more difficult for the car to change direction on the track. Every action has an equal and opposite reaction in Newton's third law. That means bumper cars weighing the same amount will hit each other and travel the same distance away from one another. However, if one car weighs more than the other, then the cart will not travel as far as the other carts.
Thrillville, amusement park destination.